This is Python8E, passing an arbitrary number of arguments. Sometimes you won't know ahead of time how many arguments a function needs to accept. Fortunately, Python allows a function to collect an arbitrary number of arguments from the calling statement. I figure you don't know what the word arbitrary is, so I did look up a definition for you. Arbitrary means based on random choice or personal whim, rather than any reason or system. When you are designing programs for users, they love to make decisions according to their own personal preferences. So it's really nice to be able to let them have one thing or three things or five things if they choose to without breaking your program. For example, here is a function that builds a pizza. It needs to accept a number of toppings, but you can't know ahead of time how many toppings the person will want. The function in the following example has one parameter, star toppings. But this parameter collects as many arguments as the calling line provides. So the big difference you notice here is the asterisk, or star. Let's call it a star, in the parameter name. The star in the parameter name tells Python to make an empty tuple called toppings and pack whatever values it receives into this tuple. You remember, a tuple is a list that can't be modified. The print statement in the function produces output showing that Python can handle this function call if there is one value, and then there's a call with three values. It treats the different calls similarly. Note that Python puts the arguments into a tuple, even if the function receives only one value. So you may expect that if there's only one, it's pepperoni, this would be a string. Wrong. It is a tuple with one item in it. Now we can replace the print statement with a loop that runs through the list of toppings and describes the pizza that's being ordered. The function responds appropriately, whether it receives one value or three values. This syntax works no matter how many arguments the function receives. Notice we are treating this as a tuple, which in this case feels very much also like a list, even if there's one thing. We don't need to have an if statement. We don't need to have to test how many there are. We simply loop through them. If you want a function to accept different kinds of arguments, the parameter that accepts an arbitrary number of arguments must be placed last in the function definition. So in this case, we've added another argument, size. We have to put toppings after size because it's the one with the star. Python will match positional and keyword arguments first, and then anything that's left, it says, oh, that must go into toppings. In the function definition, Python will store the first value it receives in the parameter size, and then everything else, it will go into that toppings tuple. The function calls include an argument for the size first, followed by as many toppings as are needed. Now each pizza has a size and number of toppings, and each piece of information is printed in the proper place, showing size first and toppings after. So when make pizza is called, the first one would say, making a 16-inch pizza with the following toppings, pepperoni. And the second, making a 12-inch pizza with the following toppings, mushrooms, green peppers, and extra cheese. By using this syntax, you can't limit how many toppings. So, again, if users are idiots, they could order 25 things on their pizza. Sometimes you'll want to accept an arbitrary number of arguments, but you won't know ahead of time what kind of information will be passed to the function. In this case, you can write functions that accept as many key value pairs as the calling statement provides. An example of this might be an online form with several optional boxes that some users may fill in and some may not. In this example, we're building user profiles that were probably filled out in that way. They chose some boxes to fill in and can leave others blank. So you know that you're going to get some information about a user, but you're not sure which pieces of information you're going to receive. The function build profile in this example always takes in a first and last name. So those two are probably required in a form. But it will accept an arbitrary number of keyword arguments as well. So in the definition here of build profile, it's expecting that first and last name, these two parameters right here. And then it allows the user to pass in as many name value pairs as they want. Note the double asterisk. These double stars before the parameter user info cause Python to create an empty dictionary that is called user info, and it will pack whatever name value pairs it receives into this dictionary. Within the function, you can access the name value pairs in user info just as you would for any dictionary. In the body of build profile, we start by making an empty dictionary called profile. So Python makes a dictionary called user info, but we're going to build a big dictionary profile so we can include the first name, the last name, and all the user info. So at 1, we add the first name and the last name because we know we have those. At 2, we loop through the additional key value pairs in the dictionary, user info, and add each pair to the profile dictionary. Finally, we return the profile dictionary to the function call line right here. So we've looped through the automatically generated dictionary and added it to our dictionary profile. We call build profile, expecting this return profile to go into user profile, the variable here. We will pass it the first name, Albert, the last name, Einstein, and then the two locations that we have filled out. The two dictionary items that we have filled out, location, Princeton, and field, physics. Those keys and values will go into user info. So the return dictionary will contain the first and last name and the location and field of study. This function would work no matter how many additional key value pairs are provided in the function call. We could collect date of birth. We could collect eye and hair color. We could collect clothing size if we were running an online store. Anything we want, we could collect. And so you can mix positional and keyword and arbitrary values in many different ways when you're writing your own functions. And at first, you may struggle to figure out which one you need to do. It's important to know that they all exist because you will see them when you read other people's code. It takes practice to learn to use the different types correctly and to know when to use each type. For now, remember to use the simplest approach that gets the job done. As you progress, you'll learn to use the most efficient approach each time. And here are some assignments because it is the end of 8E.